section 3.2, we're looking at things about the graphs of functions, and then we'll have a little algebra at the end with difference quotient. The first idea we have is whether a function is increasing or decreasing, and you just look at the part of the graph. So I'll try to hold my pointer there. Hopefully it will show up for you. So you want to look at the part of the graph that's climbing. So this left piece of this parabola is climbing. When you write the interval for it, you always talk in terms of x. So you want to know going left to right. So it is increasing from negative infinity to -4. That's where it turns around and starts down. So that will be our first interval, negative infinity. And you always use parentheses with both sides when you're talking about increasing, decreasing, or constant, because it turns around. So we want negative infinity. To, I said -4 is the x value. Right? Decreasing, it starts decreasing at -4, and that goes to infinity. So -4, infinity. And this one is not constant. Constant would be a horizontal line. So we will say DNE. And we're good there. So mainly just remember, you want to talk in terms, you want to look at it in terms of x, because you're going left to right, and always use parentheses with both pieces. All right, so then I went to 4. And I don't know really why I picked this one. It is only increasing because as you go from left to right, it is climbing. So it is only increasing. The others are going to be nothing. It starts, sorry, I'm having a little trouble seeing some of these. So it starts at -6, and it stops at 7, but you still want the parentheses. So it is increasing. We'll do parentheses to parentheses, and our leftmost is -6, and the rightmost is 7. It is not decreasing, and it is not constant. You guys stop me if you have a question. All right, and I also picked 5 because this one does have a constant area, so we could see all. It has a decreasing section over here from negative infinity to -4. It's decreasing, and then it's constant from -4 to infinity. It is never increasing. It is decreasing from negative infinity to -4. It is constant from -4 to infinity. All right, so that is increasing and decreasing. next we'll look at maximum and minimum. And this is the highest or lowest point in an area, so in a neighborhood, and you don't use the endpoints. So this one has a relative max right here, and it has a relative min down here. They can have more than one. You have to pay careful attention to how you're asked it. Where it is the x coordinate. The value of it is the y coordinate. So we have you know what, I didn't write anything down in the notes for those others. Sorry. For people who want notes, that's too bad, huh? Sorry. All right, we'll write something here because I need it to help me remember. So the relative max is at -4, 1. That's the point. It is at -4. The value is 1. So the x value at which the function has a relative max or min. So this is asking you, it's saying x. So this is -4. And what is the relative max is the value. So this is 1. Right, and let's go ahead and get the min before I scroll on down. Right, so it is at -2, and the value is -7. And you notice their wording was a little trickier, the way they ask it. So be careful with those. Then I wanted to look at 10 before we look at 9. So this one's also going to be max and min. So it has 2 relative max points, right? And so one is at -4, 0. And the other is at 4, 0. We'll go ahead and put the min is at 0, -2. All right, so the x value at which the function has a relative maximum is -4 and 4. The value of them is 0. The relative min, the x value for it is 0. And what the min actually is, the value is -2. All right, now I wanted to go back to 9. So for this one, this is your cube graph, which we haven't said what the graphs are yet, but you're not going to use the ends, and it makes kind of a curve, but it doesn't go back down from there. it does a little curve and keeps going up. Also, this one, it's curving here, but it didn't go down below. So this one does not have a max or a min in it, a relative max or a min. So it has none. Whoops. So I thought that one might be a little tricky too. But it doesn't dip back down. All right. Next we'll look at symmetry. And I sent you out a little handout or a link to it on your invite. Because in the notes, I talked about odd and even, and I did not talk about symmetry with respect to x. The reason that I didn't when I did that is this chapter is supposed to be on functions, and if it is symmetric to the x-axis, it is not going to be a function. But anyway, is a question or two, like right here, that ask us, and so I don't know if I can pull that up. Let me see if I can pull it up really fast. If not, I will just tell you how to do it. So, File Explorer. Actually, if I look at my announcements, it'll open from there. So, give me 1 second. It's a short little thing. I just wrote it out for you. All right, and we'll put it over here. See if we can even make it smaller so we can actually work with it up there. All right. So when you're looking for symmetry with respect to the x-axis, and that's the first one they ask us, you plug negative y into y and see if you get back the original. So this first problem, great. All right, so for the x-axis, we're going to do negative y into y. Maybe if I put it over here. Okay, it's not going to do that. All right. So I'm going to put negative y into y, and does it give back the original? This is for the first choice. So we're leaving the x alone. And this one does give back the original. See, that is the same as your original. So it is going to have symmetry with respect to the x-axis. For symmetry with respect to the y-axis, so this is with respect to x, right? With respect to y, you plug negative x into x and see if you get back the original, right? So I'm going back to the original. I'm putting negative x into the x. And this is not the original. And so this is no. For the origin, you have to plug into both. Negative x into x and negative y into y. And does it give you the original? It's not going to, because if this was squared, it would, because then it would get back positive. But so if we put negative x and we put negative y, right, we get negative x and y squared minus 1, not the original. So this is with respect to the origin, and it is not. So we only have the first one. All right, and Then I picked 13. And this one, we're going to work on these graphs later, even though they're not functions. But it's a circle. So you might think about the picture of a circle. But right now we're just looking at symmetry. And it says, is it symmetric with respect to the x-axis? So you plug negative y into y. You plug the opposite one in. So with respect to x, plug negative y into the y. And does it give us the original? It does, because when you square it, it gets rid of that negative. It gives you back the original. So yes, it is symmetric to x. I'm going to look at with respect to y. So that is when you plug negative x into x. And this one works. And then with respect to the origin. So you plug into both. And these exponents make this happen. So it is symmetric to all. So it's a circle and its center is at 0, 0. So you can kind of think of that. All right. Next we'll go to 14. And this is more what I talked about in the regular video with your notes, is odd or even. And odd is going to, so we're not going to have symmetry with respect to x here. So these are going to be functions. So if it's symmetric and you're looking at the picture, symmetric to the y-axis will be even. So it's going to look the same on the left as the right of the y-axis. So the first one is, it's the same on both. So it's going to be symmetric. It is going to be even because it is symmetric to y. Right, and we can just look at we have to choose even. All right. This one, you don't want to be tricked by this parabola. It is slid, so it's not going to be symmetric to the y-axis. It's actually symmetric to this other line. So it's not going to be symmetric, and it's not to the origin. So it's not symmetric. It's neither. So our second one was neither. Our third one, this one is going to be odd. It is symmetric to the origin. If you rotate it 180 degrees, it's going to give you back the same picture. All right? So this one is to the origin. And the origin is odd. Sorry, I switched up my things there. That's 14. Let's see about 15. All right, so just kind of looking at it, it does flip across the y-axis, so it's going to be even. It is not odd. It does not give you the same picture in quadrants on the diagonals there. So it's not going to be odd, and it has some symmetry, so it's not going to be even. So this is symmetric with respect to the y-axis when it's even. All right, and I picked one more of these. 17. And this one had the little shortcut in your notes. If you look at the exponents, if all the exponents are odd, it will be to the origin. If they're all even, it will be to the y-axis, it will be even. And if you have a mixture, it will be none. So we can get away with that here, or you could do it algebraically plugging in. All right, so they're just asking us odd, even, or neither. Your exponents here, you have 2, and your exponent here is 1. So this is a mixture. It's going to be neither. All right, the next one, for this x to be in the denominator, its exponent is -1. And this is x to the first. So those are odd. They're both odd, so it's going to be odd. Right, and this one, I had to think about this one a little bit. I had to think about the picture, really, on this one. It is a horizontal line. It is y equals 5. So it's going to look something like that. So it is going to be symmetric with respect to the y-axis. It's the same going across here. So it is going to be even. So sometimes you have to think of things a little different way. All right. Next, we have a summary coming up, number 19. And they're going to ask us a lot of questions about this picture. So it's important to make sure you can answer all these kinds of questions. So I know we'll have domain and range. And we'll have to look at the questions for the rest. It'll ask increasing, decreasing. I can write those. Constant. It will ask max or min. All right, so first question is the domain. So leftmost point is going forever that way, and rightmost point, as you go out, it will go to the right. So this is going to be -infinity to infinity. Right, your range is going to be lowest to highest. And let me write those next couple on my list. So the lowest point now, range, you're looking at your y-axis. Lowest point is 3, and you are touching it. And you're going forever up. Increasing. This is increasing. I should probably fill these in. It may not even ask that. Right, interval. Bracket 2 parentheses, 3, comma, infinity. All right, we do. So we'll go ahead and do the intercepts next. this graph does not cross the x-axis, so there are no x-intercepts. There is one y-intercept, and it looks like it is right here at 7. So we can put those in. This one does not exist. This one is at 7. All right, now it's going to do increasing and decreasing. So increasing on this piece right here increases. So it starts at -2 to infinity is increasing. Right, decreasing only this tiny little piece right here. So from -3 to -2 is decreasing. Constant, all of this is constant. So coming from -infinity up to -3. Right, and let's go ahead and pick off it has a minimum, it has no maximum, because you can't use the endpoints. So we have -2, 3 is the actual point. This is where it is, and this is the value. So let's see what all we can fill in now. So where is it increasing? Let's just look at the key, because I wrote them. So it is increasing from -2 to infinity, decreasing -3 to -2, constant -infinity to -3. All right, any x value for which it has a minimum. So they want the x, and that will be -2. This piece of it is -2. All right, and what the value is will be 3. All right, and there is not a max, so no max, so there would be none here. All right, and we have a couple of other questions here, so we can go back on it. So f of -3, and they want the x value when f of x equals 3, and then they want to know if it's odd or even or neither. So f of -3. So when x is -3, where is the picture? And it is at 4. Right? This says y is equal to 3. Where is x? So y is equal to 3. Where is x? X is at -2. Right? And for symmetry, you could not flip across the y-axis, so it's not even. And if you rotate it, it doesn't look the same down here. So it is neither on those. All right, and so we said f of -3 was 4. Good. And when y is 3, x is -2. And we said neither on this one. So that's a good question. I'm sorry it's hard to see it. It's hard to see it and work out the answer and look at the questions at the same time. Right, our next one, and this is really the most challenging questions in this section, are the piecewise functions. The first question's easy. Okay. Because it is really just picking the right rule. So you have two functions, two pieces defining it. So it's piecewise in pieces for certain areas, right? And then you put them on the same graph. So this first one is just plugging in, and it's making sure you plug in the right rule. So f of negative 6, right? Negative 6 is less than 0. So you have to plug in to the top rule. So 6 times 8 is 48, minus 7 will give us 41. Right? And then it says f of 0. So you want to pick the right rule. It will be the one with the equals under it. And so it will be negative 9 times 0 plus 5. So 0 plus 5 is 5. Right? And then f of 6. Right? 6 is bigger than 0, so you have to use this rule. So negative 54 plus 5 will give us negative 49. So it's just picking the right rule with the conditions. All right, so that one's easy. And then this one just has 3 rules. And you pick the right rule. So 23 is the first one that'll give us a little bit more work. And graphing these, I put a little handout in your chapter notes because this is tricky if you haven't ever seen it done. Just using the tool. All right, so hopefully you recognize that these would both be lines. Let me write the question here. So f of x equals negative 3x plus 3. And my condition is when x is less than 0. It equals the other function when x is greater than or equal to 0. Right? So I'm going to change it and make it look like a line. And I'm not going to graph it with slope-intercept, which would be an easy way to do. I'm going to use a chart because I'm only going to have part of the line. I'm not going to have the whole line. And I need to use this value that's on with the condition. So I'm going to need to use a 0. I'm going to put a star by it because it will either be an open or closed circle. It will be open because there's no equals underneath. But we'll plug it in and see what we get. So we plug in 0. So we have y equals negative 3 times 0 plus 3. This is 0, so y equals 3. Right? And then we'll take another value. Our other value has to meet this condition. So x has to be less than 0. So let's just pick a negative 1. So y equals negative 3 times negative 1 plus 3. This is 3 plus 3 is 6. Right? And we can draw that on there. Let me go ahead and figure out the points for the other one. I'm going to erase this where I worked, so somebody will have to watch the video to see how I got those points, if they're not here. All right, so for the other one, it is also a line. And so we want to use 0, and we have an equal, so it'll be a solid circle. We plug it in. So 4 times 0 is 0 minus 2 is negative 2. And then we want something bigger than 0, so we'll pick a 1. So 4 times 1 minus 2. So 4 minus 2 is 2. All right, now we're going to go to the graph. And for this endpoint, this one needed an open circle. So your first thing you're going to pick is this open circle, and you're going to put it on 0, 3. So don't go over, go up 3, and then you'll click. Right. Then you're going to click this ray tool, which is the second one. So we'll click that button because the line's not going to extend forever, right? So it's a ray instead. And we have to click on this point again, and that's the tricky piece, right? So we're going to go start from there, and then our second point on it is going to be -1, 6. Click, and that will make our graph. Now, you have to just remember, if you do these right, the ends, because they all look filled in on there. All right, now I'm going to do the other picture. So this one had an equals underneath, so I need to do the solid circle. And I want 0, -2. And then I'm going to click the ray tool. Then I have to click this point again because that's where I'm starting. And then I want the point 1, 2. Now, let's see if it will check that much. It's going to make me work before it checks that much. All right, because we're going to check this one. All right, your range is looking at both graphs, the lowest to the highest. And let's see, this one came off the second graph and it had an equals to it. So our range is going to be -2, and both of these go up forever. -2 to infinity. And we'll put these in so we can see if I got the graph right. Hopefully. Right, and then they want to know f of 0. When x is 0, what is it equal to? And you could do that algebraically, or you can look at your picture. You have to just remember which endpoint it really is. So it's going to be one of these two endpoints. It's going to have to be this one with the equals. So when x is 0, it is -2. It's going to have to be this one. This one had the solid circle, and the other one has the open circle. It would be better if it didn't fill them in the way it looks when you look at it. If I had like a save button or something. Okay, and Mrs. H missed something. Wonderful. Wow, I missed all of it? Really? You know what? Because I put it in the wrong... I entered it on the wrong grid. Okay, that was for a different question down there. So let's see if Mrs. H can enter it on the right grid. This one is 23. Okay, and so we have the right information. We just put it in the wrong grid. Did you guys know I was doing that? All right. And it's hard to see where we are. All right. So it'll be good practice with the right tools. So we'll do the first line. And this one had no equals underneath, so we have to use open circle. So open circle for our end at 0, 3. So don't go over, go up 3. All right, we're going to hit the ray tool. We're going to hit this one again. And then we're going to do -1, 6. All right. Then we're going to hit close circle, because as the equals underneath, we're going to graph the second one, 0, -2. So don't go over, go down 2. Going to hit the ray tool, click this again, and from there we're going to 1, 2. Right? Our range will be from -2 to infinity. And f of -3. When x is -3, where is the graph? And so that's not showing up on our picture so easy. So let's do it algebraically. So you just have to make sure that you use the right one. So f of -3, right? You want the rule when x is less than 0. So -3 times -3 plus 3. So this would be, whoops. This would be 9 plus 3, 10, 11, 12. All right, better if you get it on the right grid. Okay, so we practiced there. Let's see. How are we doing for time? So 24 was one I had down to do. And we'll get a new question. And you have to look at these little notes because that will help you with the range when you have this one value. So f of x is equal to -8. So that's going to be a special line. And this one's also a line. And this one, x is less than or equal to -5. So what we have is y equals -8, which is a horizontal line, but we need points to graph it. And we need to use -5 at the star, and this one's going to be closed. The y has to be -8. For another value, we need to be less than -5. So on that negative side, remember that would be like a -6. Right, so that's for our first one. For the other one, y equals 2x plus 5. And that's a line. Your exponents are 1, and it's in slope-intercept form. All right, we have to look at the -5, and this will be an open circle because there's no equals underneath. All right, so we'll plug in -5. 2 times -5 is -10 plus 5 is -5. And then we will do higher than that, so we can go to -4. Let's go to 0. 0 is higher than that. So 2 times 0 is 0 plus 5 is 5. All right, so now we can put these on. And so for our first one, this is a closed circle. So we want -5, -8. And we want the ray tool, and we want to click that one again. Go back there. Oops. All right, it's not liking that. Okay, I guess it does not want me to click it again. All right, negative 6, negative 8. Yeah, that didn't work. All right, we'll start it over. All right, we want a closed circle on negative 5, negative 8. Then we want an array from there, and we want negative 6, negative 8. All right, so we're good with that one. All right, on the other one, we want an open circle on negative 5, negative 5. And that's an open circle. And then we want to do the ray tool. Then we'll click here again, and we will go over 0 and up 5. All right, and there is our graph. And it's going to ask us range. Your domain is going to be negative infinity to positive infinity with these piecewise functions. So your range, the lowest point on here is negative 8, and we said that one is including. And this is where you need this special notation because it's only that one value. So it's going to be negative 8, comma, negative 8. Just that value. All right, we're skipping this piece, so we have to leave it out and do separate. All right, and this one was an open circle, so it's going to be a negative 5 with a parentheses, and then it goes forever up. So that should be our range. And I don't know what else they asked us. F of negative 7. Right, so when x is negative 7, it is less than this negative 5, so it is going to be negative 8. It would be on that, or you could look at the picture there. So negative 7, it would be here. You could see that one pretty good. All right, so let's see if we can type these in. So we want bracket to bracket. And that was special notation that it warned us about. Union, and we want parentheses to parentheses, negative 5, comma, infinity. And f of negative 7 we said is negative 8. And we'll submit. I wanted us to be able to see if we had the graph right. Good. All right, 25. How's my time going? Let me skip this one and come back to it. We will do it with a calculator if we have a chance. Right, it would take a lot of time and I wouldn't get to the others. So we'll come back to it if we have a chance with the calculator. So let's look at 26, and these are algebra questions. So totally different from what we've been doing. And what we're finding is called the difference quotient, which is this here. F of a plus h minus f of a over h. And they give us our pieces. So f of x is this. For this first one, they lead you in steps. All right. They want you to find f of a. This means to plug the a in for all the x's. So it is 6a minus 1. Then they want us to find f of a plus h. So we have to plug a plus h in for the x, and you need parentheses because you want the whole quantity in. And then you need to clean that up. So 6a plus 6h minus 1. And then they want us to find the difference quotient. So we're going to use this f of a plus h, which we found right here. Right, and we're going to subtract f of a. So f of a is here. So if we subtract f of a, we're going to distribute that. So we're going to have negative 6a plus 1. That's what's going here. And I could have done the parentheses and the negative here. All right, and all of this is over h. Now, when you do these, you're going to get a bunch of canceling. So let's see what all cancels. The 6a and the 1s. So what we have left is 6h over h, which just equals 6. All right, and I didn't put any of these in, but we can just check. 6a minus 1, that's our f of a. And there we go. And this one, all you want is the simplified answer. So it's algebra. You do have to be really careful with them. Right, let's look at 27. This one you have to be more careful. So our function is, f of x equals 6x squared plus 2x plus 4. And we're going to find the difference quotient. But it's helpful if you find these pieces you need first. So let's find f of x plus h. So you're going to substitute the whole quantity for every x. So 6 times x plus h plus 2 times x plus h plus 4. Right? Sorry, this is squared. That's important. So that means you're squaring a binomial, which is x plus h times x plus h, which is going to be a FOIL. So I'm going to do that before I multiply by 6. So x times x is x squared. Outside you get xh, and inside you get xh. So you're getting 2xh plus h squared. And now I'm going to distribute this 6, right? And I'm going to back up. So I have 6x squared plus 12xh plus 6h squared, right? Now I'm going to distribute this 2. So I have plus 2x plus 2h plus 4. All right, that's only the first piece, right? Now I'm going to subtract f of x. Well, here is your f of x. If you distribute a negative through that, that will be subtracting f of x. So negative 6x squared minus 2x minus 4. All right, so I'm going to have to tag it on here. All that's on the numerator. Denominator is just h. All right, so now we'll see what all cancels. So our 6x squared cancels. Our 4 and our negative 4 cancels. Our 2x and our negative 2x cancels. And that looks like all. So what we have left, we have 12xh plus 6h squared plus 2h all over h. Now you have a choice here. You could factor the h out of the numerator, or you can see that you have it in every single term. So you can just divide it with the denominator, whichever you're more comfortable with. It will leave you 12x plus 6, and you got one of them left, and plus 2. So 12x plus 6h plus 2. Good. So I didn't make a little silly error. So you have to be real careful doing these, but it's not a hard thing to do. All right, let's look at 28. So that's all of those. And 28, I think we are just looking at some different graphs. And we need a bigger space here. All right, so we're going to consider this function, and we're going to give the intervals that it's talking about. So it's talking about increasing, decreasing, constant. So A is increasing. Where is it increasing? B is decreasing. C is constant. D is domain. And I can move this so it doesn't do that. And E is the range. All right, and it's going to have more than one section. So increasing, you have a few sections, so be careful. So here is increasing, then we're decreasing, then we're constant, then we're increasing, then we're constant. So I had two increasing from negative infinity to negative 7. Remember parentheses on increasing, decreasing, right? Decreasing here, constant, increasing in this part. So from negative 2 to negative 1. And that's all the increasing. All right, and we'll just look at the answers rather than type that. Okay, we're good there. So, decreasing. All right, so this is increasing. Right here is a decreasing piece. And then we have constant, increasing, constant. So only one decreasing part, and that is from negative 7 to negative 5. Good? All right, where is it constant? You have two spaces here and over here. So from negative 5 to negative 2. And from negative 1 to infinity. Good? All right, domain. This side it goes forever to the left, this side goes forever to the right. So domain is negative infinity to infinity. Good? And range, lowest to highest. This end of it goes down forever. So it's going to start at negative infinity. And it doesn't have any gaps in it. The highest point it can go, though, is right here. So the highest it can go is 4. Now, it is touching it, so you will use a bracket. So negative infinity to 4. All right, so that's analyzing the graphs a lot and learning how to pick those things off. All right, let's back up to 25 and see if I can show you this one with the calculator. So I'm not going to do that one by hand. Right, it is a piecewise function. This part is a parabola, and it's a multiple choice graph. All right, so, and this takes a special button that we haven't used. I want to make sure my whole calculator screen is showing there. All right, to put a condition in. So I wanted you to see that. Hopefully I remember how to do it right. Okay, so we're going to do, get my mouse back up here. No, wrong button. So y equals, we'll do parentheses, x plus 2, close parentheses, raise it to the second power, minus 4. Right, now we're going to put this condition that's after it. So you're going to do a divide, and you put your condition in parentheses. Right, so we're going to do x. Your conditions are under the test menu. So you're going to do second test, so it's really the math then. And I need less than, plain less than, which is number 5. And then I want -2, close, right? And I'm going to put the other function in, so I'll do a down arrow, or I could do it equals. All right, 3x plus 5, so that one's a line. Right, we'll put its condition in. So divide and then condition in parentheses. X, right, greater than or equal to, so we go back to the test menu. And it is number 4, -2, and close the parentheses. All right, and let's tell it graph. All right, so we're going to match it to our graphs. It doesn't tell you about the endpoints, the open or close, so you have to look at your things and work with that. For the line, which is this one, it has the equals underneath, so it should have a solid dot. So this one is out, even though it looks like our picture. So it is not this first choice. But I had to look back algebraically to see that. All right, and we said the parabola gets an open circle and the line gets a solid circle. So that second choice looks pretty good. All right, so we'll kind of keep that one in mind. Let's go down to the next one. This one has open circle with the parabola, so that is not right because we said it's getting closed. And this one doesn't look like our picture at all. So choice number 2, and we'll look back and verify. These your inequalities had to help us because the calculator doesn't show that piece. All right, and so for the parabola, it needed an open circle on the end. So that ruled out the first one. This one's good. And it looks like our picture. This one is not good. And this one is not good. So it is choice B. All right. And I didn't answer the whole thing. So they want the range and they want to know f of -8. All right. So we'll go back up to our picture for the range. We chose this one. So your lowest point is -4 and you're not touching it. And it goes up forever. Right? And f of -8, you don't see it on your picture, so go back and do it algebraically. Right? So -8, you need the top one. So you want -8 plus 2 squared minus 4, because x is less than -2. So this gives us -6 squared would be 36, minus 4 would give us 32. So we said range is -4 to infinity and 32. All right. We'll stop there. I actually got through all of them that I had planned. So I'll turn the record off, but if anybody wants to hang out and